Welcome back. Today we'll be focusing on taking the integral of cosine squared of x dx. So typically what I like to do before I approach an integral problem is just to list out the different types of integration techniques, just to really refresh what's out there for me and what I could potentially use to tackle this problem. Even if it's not something that might work, it's just nice to see what's out there. So I know there's regular integration. So let me just put this in brackets. Regular. By regular, I mean like if you have the polynomial x to the power 4, regular could mean like x to the power 5 or 5, or like sine of x, the integral of that is going to be negative cosine of x. So that's what I mean by regular. It's like something that you just got to know. We have regular integration. We also have trigonometric substitution, which is particularly interesting, I think, because this question is related to trigonometry. So trigonometric substitution, let me say trig sub. We also have u sub. And finally, in the course, we also have integration by parts. Let me say IBP. So these are all the choices that I have available to me. So what I can do is just try out different things and see where it takes me. So if I'm looking at u substitution, sure, what can I do? Perhaps I could say that my u is cosine of x, or even cosine of x squared. But let's just see where this goes. If we take the integral of this, if we take the derivative of this, is it going to be cosine negative sine of x dx, and immediately we see that we've sort of run into a problem, because typically with u substitution, what we would like to have is we would like this term to be related to sort of look this term, the product of this term and u, so the product of u and du, or something along the lines of that, to look like the integral we have up here. But unfortunately, that doesn't seem to be the case, because we can't identify a sign over here. It's just cosine squared of x. So perhaps we could try cosine squared of x and see where that takes us as u. So cosine squared of x. Du is going to be the derivative of this. So we're going to take the derivative of the outer function, because this is a chain rule problem. So the derivative of the outer function is going to be 2 times the cosine of x, so 2 times cosine of x, so we're going to say 2 minus 1, which is just cosine of x. Just going to write that out. And we're going to take the derivative of the inner function, which was cosine of x. The derivative of cosine of x is negative sine of x. So that's going to be negative sine of x. And once again, we see that this the product of these two, or perhaps like some manipulation done to this, done to the u, and just leaving du as it is, we can't really seem to get into the cosine squared form, because it doesn't really, it just doesn't, there's just a sign over here, and that sign's really just messing things up for us. So we know that we can't use substitution in this instance. So let's see if we can, so we can just say no to this. Perhaps we could try regular integration. So I'll just open up new layer, change the color. Okay, so this is a problem again. So just use this pink, cosine squared of x d. Ooh, that's out of the screen. Let me just get this in. So integral of cosine squared of x dx. So no to u sub. What about regular? Well, let's think about regular. So regular means like something that that we're familiar with, like the integral, like something that we just have to memorize. That's typically my definition of regular. So that includes things like the integral of cosine of x dx, which is, as I said before, negative sine of x plus c. Sine of x plus c. negative sign is when you take the derivative. And something like integral of sine of x, or the integral of like u to the 4, which is let me just say x to the 4. X to the 4 dx, that's going to be equal to x to the 5 over 5 plus c. So this is typically what I consider as regular. But in this instance, I don't think many of us have seen cosine squared of x before. So once again, I don't think we can really classify this as regular. Let me just change this. Say, let me just reaffirm this. So yeah, we can't really classify this as a regular integral. So we can also try out integration by parts, but at this point it just seems to be cosine squared of x dx. So there doesn't really seem to be two obvious functions popping out. You could say one, but that wouldn't necessarily lead you anywhere. So we can choose to forego integration by parts. So finally, let me just use a new color. Finally, we have trig substitution. This is not nice. Okay, this blue is nice. It's trig substitution. So trig substitution is, I think, particularly relevant in this problem, because this problem is the integral of a trig function. So trig substitution seems like it could work out quite nicely. So that's what we're going to go with. So we got to figure out a substitution involving cosine squared of x dx. So typically what I like doing is looking at all the cosine identities. So one of the cosine identities that I know is cosine of 2x, which is in essence just cosine squared of x minus sine squared of x. And immediately I can see that there's a cosine squared of x term here. But particularly what seems to be appealing to me is that there isn't a square over here. There doesn't seem to be a square term over here. It seems like I can use regular integration in order to solve this problem. But I still have a problem of dealing with sine squared x. So let's explore this substitution a bit more in a bit more depth. So integral of cosine squared x dx. Always got to write out the problem. So we have cosine of 2x equals cosine squared of x minus sine squared of x. So what I'd first do is, let me just say like cosine of x squared, or cosine squared of x, equals the cosine of 2x plus sine squared of x. So in essence, what I'm just moving around terms so that I isolate cosine squared of x. But something that comes to my mind when I see sine squared of x, or even just cosine squared of x, is the Pythagorean identity. And that states that, let me do this in a different color actually. So the Pythagorean identity states that sine squared of x plus cosine squared of x is 1, right? So what I find to be intriguing here is that I have a cosine squared of x term, and I also have a sine squared of x term. So I know that both of these sort of fit into the equation, and since I want to write my equation in terms of cosine squared of x, that seems to be ideal. So what I'm going to do is isolate sine squared of x. So let me say sine squared of x equals 1 minus cosine squared of x. So this would lead me to write my new equation as cosine squared of x equals to cosine of 2x plus 1 minus cosine squared of x. So it seems to be working out, because it seems like I can isolate cosine squared of x. So let's just go through with it. Let's just bring cosine squared of x to this side. So we have 2 cosine squared of x equals to cosine of 2x plus 1. Okay, so let's go on to another page. So 2 cosine squared of x equals to cosine of 2x plus 1. So this seems to be really interesting. It seems that now if I divide both sides by 2, I've rewritten cosine squared of x in terms of cosine of 2x. And as I mentioned before, this seems to be a regular integration problem, and thus it makes it doable. So what I can do now is go back to my original integral, which was cosine squared of x dx, and that is equal to, now with the new substitution I performed, cosine of 2x plus 1 over 2 times dx. So it just becomes a case of evaluating the integral now. So I can just split this integral up. Let me split it up into cosine of 2x over 2 dx plus the integral of a half dx. So what I can do is, okay, so what's the integral of cosine of x? Cosine of x is sine of x. I also know that taking the integrals like anti-differentiation. So whereas for differentiation I would multiply the differential by times 2, I'd just divide by 2. So this is going to equal to a fourth, because there's already a half over here, so it's going to be 1 over 2 times 1 over 2, which is 1 over 4, sine of 2x plus the integral of this term is just going to be a half x, and it's going to be plus c. So there you have it. This is the integral of cosine squared of x evaluated. So now the concept here is to take something that's really complicated and just trying to bring it into a domain where you can play with the function and actually solve it. So whenever you do integration, I'd recommend that you should try to get down to regular integration. Regular meaning like something that you can do without thinking. So thanks for watching, and catch you guys in the next episode. See you.